Hi, I'm Bob. Welcome back to the Stata course on regression analysis and estimation methods. Today, we will explore the binary response models. It differs from the models we discussed in previous videos in the outcome variable. If the outcome variable is a binary variable instead of a continuous variable, then the model is called the binary response model or the binary choice model. A continuous variable is a variable that can take on any value within a range, such as age, years of schooling, and hourly wage. By contrast, a binary variable takes on only two values, 0 and 1. We often see binary variables like female, living in the South, married, union member. The two values, 0 and 1, represent whether it is true or false. We can use the OLS method to estimate the binary response models, and such an estimation is called a linear probability model. The linear probability model is simple to estimate and interpret. However, it has limitations. The fitted probability could be less than 0 or greater than 1. Moreover, the marginal effect of the explanatory variable on the outcome variable is a constant for every value of the explanatory variable. To overcome these disadvantages, we can use nonlinear models, such as the Logit and the Probit models, for the binary outcome variables. The idea of the Probit and Logit models is that we use a transform function g to map each input to an output that is strictly between 0 and 1 for all values of explanatory variables. In other words, it ensures that the estimated response probabilities are strictly between 0 and 1. Various nonlinear functions have been suggested for the function g, and the two commonly used are the logistic function and the standard normal cumulative distribution function. Let's open the HAPPINESS.dta dataset. It is from the textbook Introductory Econometrics, a Modern Approach by Professor Jeffrey Woodridge. You can download the dataset from the link below. The dependent or outcome variable, vhappy, is a measure of happiness. It is a binary variable equal to 1 if the person reports being very happy. It equals 0 if the person is not very happy. We are interested in the effects of church attendance on happiness. The two dummy variables, occattend and regattend, indicate whether the person goes to church occasionally or regularly. They are constructed based on the categorical variable attend. The base group is those who never go to church or go to church once a year. We add these two dummy variables to the model to find the effects of church attendance on happiness. We first estimate a linear probability model using the regress command. We model the probability of being very happy as a function of the two church variables and a series of individual demographic characteristics, such as gender, education, income, number of children, and race. We also include the year dummies for the year fixed effects. We specify the heteroscedasticity robust standard errors. The coefficient on the dummy for those who occasionally go to church is practically tiny and statistically insignificant. The coefficient on the dummy for those who regularly go to church is 0.11. This implies that compared to the people who never go to church, the people who regularly go to church are 11 percentage points more likely to be very happy. Then we use the predict command with the XB option to generate the predicted probability of being very happy. We summarize the true values and the predicted values, and we find that the sample means are the same for the true probabilities and the predicted probabilities. However, some predictions are below 0. Notice that the if condition, E sample, restricts the sample size to be the same as in the regression. Next, we use the Probit command to estimate the Probit model for the binary response variable very happy. We also use the predict command to generate the predicted probabilities. We use the PR option for the predicted probabilities. We find that the predicted probabilities are between 0 and 1. We can try the Logit model using the Logit command. Finally, we compare the predicted probabilities from the 3 models. We type summarize vhappy star. The star sign represents all variables that start with vhappy. We may want to know how well the model predicts the outcome. Stata provides a classification table that shows the percentage of correct predictions. We type estat classification. The overall rate of correct prediction is 69.71%, with 0.18% of the very happy group correctly predicted and 99.96% of the not very happy group correctly specified. The classification result depends on the cutoff value. The default is 0.5, which means an observation is classified as positive if its predicted probability is greater than 0.5. We can change the cutoff value. We can use the sample mean probability as the cutoff value. In our sample, the mean probability of being very happy is around 0.3. If we use this cutoff value, the percentage of overall correct predictions drops to 53.75%, with 65.33% of the very happy group correctly predicted and 48.71% of the not very happy group correctly specified. Finally, let's jump to marginal effects. There are 2 types of marginal effects. The first one is the average marginal effect. It computes the marginal effect for each observation and then averages them across the sample. Another is the marginal effect at the mean, which computes the marginal effect at the mean values of the explanatory variables. The dy/dx option produces marginal effects. We calculate the marginal effects for the 3 specifications: linear probability model, Probit, and Logit. After running the linear probability model, we type margins, comma, and dy/dx. Inside the parentheses, we put the variables we want to compute marginal effects. The post option allows us to post the margins as estimation results and store the results with the estimates store command. In the linear probability model, the average marginal effects are the same for each observation, and they are the same as the coefficient estimates. We also use the margins command to compute the average marginal effects for the Logit model and the Probit model. The average marginal effects are different from the coefficient estimates. For nonlinear models like the Probit and Logit, the marginal effects at different values of the explanatory variables are not the same. The margins command produces the average marginal effects. That is, it computes the marginal effects for each observation and then averages them across the sample. We use the stab command to list the average marginal effects for the three specifications. The average marginal effects are close to each other. The people who regularly go to church are estimated to be happier than those who do not go to church. The probability of being very happy for the former is 0.1 higher than the latter on average, after holding other factors in the model fixed. The effect of church attendance on happiness is statistically significant at the 0.1% level. The estimates of other explanatory variables also make sense. Higher educated people are happier on average. Income is positively related to happiness. The number of teenagers in the household does not significantly affect happiness. There is no noticeable difference in happiness between men and women. These are the average marginal effects. Keep in mind that for Probit and Logit models, the marginal effects are different at different points due to the nonlinear transformation from the explanatory variables to the outcome variable. To calculate the second type of marginal effect, the marginal effect at the mean values of the explanatory variables, we use the add means option. The marginal effects at the sample means for the Probit and Logit models are close to the average marginal effects. Thank you very much for watching this video. See you soon on the next topic. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.